So, TechGirls Programming Club Hackathon. We are going to start with our first code forces question. And the first question is called team. So, one day, three best friends, Petya, Vasya, and Tonya, decided to form a team and take part in programming contests. Participants are usually offered several problems during programming contests. Long before the start, the friends decided that they will implement a problem. And if at least two of them are sure about this, will implement a problem if at least two of them are sure about the solution. The friends won't write the problem solution. So basically, this contest offers n problems to the participants. And for each problem, we know which friend is sure about the solution. Okay, so basically, long story short, we have an n amount of problems, n number of problems. So in this test case, we have 3 problems and we have 3 friends. And each line contains 3 different integers. So if the first number in the line equals 1, then Petya is sure about the problem solution. Otherwise, he isn't sure. The second number shows Vasya's point of view on the solution, and then the third one shows Tanya's view. So 1 means that it is easy. So for example, if one of them, or there are 3 friends, if one of them said 1, then that would indicate that the problem is easy. If the second one said 1, then the second one thinks or views the problem as easy. And if the third one said 1, it would be easy. And if it was 0, in this case, for example, then the problem wouldn't be easy. However, in the question, at least 2 of the friends need to think that the problem is easy or that the view to the solution is very clear in order for them to include the problem in the contest, for example. So it does sound a little tricky, but it's a pretty easy solution. So for example, here we have 3 different questions. We have 2 different test cases in this problem, but the first one has 3 different questions. The first 2 friends said that it was easy. So this one passes the test. The second problem, 3 friends said that the point or that the problem solution is easy or clear. So this one also passes the test. However, in the last question, only 1 friend said that they are sure about the problem solution. So the output would be 2, since 2 different questions passed the test. And for a second test case, 1 friend said that the problem solution is clear, so this does not pass the test. However, with the second problem or the second question, 2 friends said that the problem solution is very clear, so this question passes the test and the output would be 1. Okay, so this is basically a summary of the test cases that we just discussed. Okay, so there has to be at least 2 people that think that the problem is clear and the problem solution is clear in order for them to include it in the programming contest. Okay, so I think we're ready to write the code. I tried to simplify it as much as possible. So what do you think would be our first step?
We need to declare an integer m, and then
we need to declare integer n. Yeah.
And CNN.
This is the tricky part.
Yeah, I was thinking of using nested loops.
Nested loops. Okay, so why do you think we should need a nested loop? Because it looks like a matrix?
Yeah.
So, okay, here's the thing. So basically the question here, it looks as if it's a matrix, but these are all different test cases and these are all different questions, let's say. But we repeat this loop 3 times since there are 3 questions. So nested loops here are not very necessary, and nested loops are not going to really help us with this question. So here's the hint. We are receiving 3 different variables every time, okay? And every time we are counting whether the test case passes or not. So it passes if at least 2 people that the solution is clear. At least 2. So it's something a little more different. It's something a little, nested loops are not going to really help us here. But that's a good observation. It really is a good observation. But what do you think? Are there any other different solutions? So I'm going to give you a hint. And there's something over here that we need to include. I'm going to start with the for loop. So a for loop is going to be very helpful in this situation. So what do you think? We are going through this n times. So how do I set my for loop?
And I equals to 0.
Mm-hmm.
I less than m.
Mm-hmm.
I plus plus.
I plus plus. Excellent. Okay. So what are we receiving every time? We are receiving 3 different values. And every time we are basically counting. Are each of the friends, are there at least 2 or more friends that think that the solution is clear? If so, then this passes. Second time, are there at least 2 or 3 friends that think that the problem is clear? If so, this passes. However, in the third question, only 1 friend thinks that the problem is clear, so this does not pass. So the output would be 2. There are 2 problems that they will be including in the programming contest. So what are we receiving every time?
One or 0.
Exactly. So we're receiving 1 or 0 from 3 different friends, right?
Yes.
Exactly. So
We should declare something.
exactly, you should definitely declare something. What do you think that is? Since we have 3 different friends. And we're going to treat 1 and 0 as integers for now. What do you think?
And Petya, comma.
So you want to call them by, you want to...
Or anything, it doesn't matter.
Or anything. That's true. We can go with Katya, but just for the sake of, just to ease the process, let's go with ABC. What do you think?
Yes, this is better.
This is easier. Yeah, exactly. So excellent. So Yasmin, what do you think? What are we receiving every time? Every time the loop goes, what exactly are we receiving?
Either A or B or C.
So either, or are we receiving all of them?
We can receive them all at the same time, but no, we need to store each variable in a different. We need to store one in A and like
Exactly.
the other one.
Yeah, so we already declared these variables. So we are gonna just simply ask for these variables from the user, right? So we're gonna see in A and B and C. Okay, so we're done. I'm pretty sure this is the hardest part. So we're done with the hardest part. Every time the loop goes, we are receiving exactly 3 different variables. However, we need to decide, or we need to figure out a way that would help us determine whether each question passes the test. So again, each question passes the test if 2 or more friends say that the problem solution is clear. So here we passed, second question we passed, however, the third question we did not pass the test. So the output would be 2. So I think we need to declare something else.
A counter.
Excellent, absolutely. We need to declare a counter. So we are going to declare int count 0. And what do you think we should be storing in the counter? When do we increase the counter by 1?
If A is equals 1, or B is equal 1.
Okay.
Or C is equal 1.
So we're going to stick with that for now. But what if A was equal to 1 and B was equal to 0 and C was equal to 0? With OR statements, we only need one condition to be true, right?
Yes.
So in this case, if it was, for example, 1, 0, 0, the counter would increase. However, this is incorrect, right? So what do you think would be, how do you think we can fix this?
Can we say if A plus B plus C is greater than or equal to 2?
We definitely can say that, absolutely. So if A plus B plus C is greater than or equal to 2, then what would we do?
Count plus equals 1.
Plus equals 1. Absolutely, excellent. So we could maneuver and we could fix it with or and statements. However, it would take so much more effort. The question specified that if at least 2 friends think that the problem is clear, then, so we're basically done. We received A, we received B, we received C, and of course we received N, which helped us set the range for a for loop. And all we did was set a counter that would increase if at least 2 friends said that the question was easy. Excellent. So what would be our absolutely last step? We have to output something.
C out count.
C out count. Excellent. C out count. So let's test our code before we submit. Let's test both the test cases, and I'm going to use the text property over here and see what it gives us. It's supposed to give us 2. Excellent. Let's try the second test case. Input 2. Okay. We run our code. Just want to remove that. Is it 1? It is 1. Absolutely. Okay. So this is a good question. I wanted us to start with this question just so we can warm up, since there are more. Oops. There are a little more tricky questions coming. So let's try to submit our code. Oh, I didn't enter it. Sorry, girls, just give me 1 second. Okay, sorry about the inconvenience. Okay, so our problem is team. And we're gonna try to submit our code and see if it got accepted or not. So team is running. Sometimes it takes a little bit of time, and we'll give it the time it needs. That's fine. So moving on to the second question. The second question is a little trickier, but it's also an easy question. It's called soldier and banana. And banana, sorry. Okay, So a soldier wants to buy W bananas in the shop. He has to pay K dollars for the first banana, $2K for the second one, and so on and so forth. In other words, he has to pay I times K dollars for the ith banana. Okay, so he has N dollars. How many dollars does he have to borrow from his friend soldier to buy W bananas? Okay, so the first line contains 3 positive integers, K, N, and W. And they set the range. The cost of the first banana soldier has, which is N, and the number of bananas he wants, which is the last value, which is W. Okay, so this is a tricky question as well. But a quick synopsis. Let's just check if it got accepted and our solution is accepted. So we can remove this code and use the same compiler. Okay. So basically, we are receiving 3 different integers from the user. We are receiving K, N, and W. Okay. And K is basically the cost of the first banana. N is the number of dollars the soldier has, the number of bananas he wants. And they specified. So basically, if the soldier wants 3 bananas, he has to pay K dollars for the first one, $2K for the second one, and $3K for the ith banana, which is the last banana. This is also a tricky question, but we can solve it together. So let's start with the easiest part. The easiest part is basically declaring the variables, right? So let's start with integer K and W. So what's the second part? What does the question ask us?
C, N, K, N, and W.
Absolutely. K, N, W. Okay. So how do we find the number? How do we find the amount in dollars that a soldier has to buy? A soldier has to pay in order for them to buy the number of bananas.
I was thinking of using a for loop.
Excellent. Okay, definitely. So we do need a for loop. What do we do? How do we set the values?
Okay, so first, int I equal to 1.
Excellent. Okay.
Okay, I is less than or equal to W. I plus plus.
I plus plus. Excellent. Okay, so what's the second step? We need to find the number of dollars that the bananas would cost. So again.
Okay, so we need to declare declare a variable to store the number of dollars all of them would cost.
Absolutely. So how do we do that?
Okay, so int A, just
okay,
int A equal to 0.
Excellent. Okay.
Okay.
Great. So we're almost there. Yeah.
A is equal to I times K.
I times K. Okay, so that's for the first banana.
Yeah.
Right? But we need to find, or technically it's not for the first banana. It's going to keep on changing. We need to find the sum of all of them, right?
Yes. So, okay, and we need to add, like...
We need to find the total.
A plus equal I times K.
Excellent. A plus equals. Bravo. So it's plus equals because we need to find the sum in order for us to find the total. So the sum of each time they need to pay for the banana. So for the first time, it's going to be 1 times K. The second time is going to be 2 times K. And the third is going to be 3 times K if W is 3. Okay? But we need to find the sum. So if we left it as A equals I times K, it's only going to store the last value, which is 3 times K. Excellent. Okay, so what would be our next step? We need to declare if this soldier needs to borrow money from his friend. So we already used K and we already used W. And N is the initial number of dollars the soldier has to pay for the bananas.
We see out A minus N.
See out A minus N. Excellent. Okay. So I'm going to ask you another question. So what if the soldier did not need to borrow from their friend? What would that case be?
0.
See out 0. So when would we have to see out 0?
When A is equal to N.
Exactly. So when A is equal to N, or when A is greater than or equal to N, right? Since we need to cover all the possibilities. Sorry, it's the other way around. I think I mixed them up. I'm sorry. So basically, this N is the initial number of dollars the soldier has. But if something, which is the condition over here, we would have to see out 0. Since in this case, if this condition was true, so when would that case be true? When would the soldier not need to borrow money from his friend?
If A is less than or equal to N.
A is less than or equal to N, exactly. Or if N is greater than or equal to A, it's basically the same thing. So let's try to run our code and see. I think this is a tricky question just because of the numbers. There are so many different numbers that we're working with. So let's try to run our code and see what it gives us. So it gives us 13. So apparently, the soldier needs to borrow $13 from his friend. So a quick synopsis. We asked for K, we asked for N, and we asked for W. And W is the number of bananas. N is the number of initial dollars. And K is the cost of the first banana. And the cost keeps on increasing since we set the equation as I times K. And we found the total and we stored it. Okay, so in the case that the soldier has enough money to pay for the bananas, we would see out 0 since the soldier would not find the need to borrow any money from his friend. But if the soldier does need to borrow money, then we would have to say A minus N, which is basically the difference.
Shouldn't we add else? Because because if the condition of the S statement was true, it will also print A minus N.
Excellent. I actually wanted us to see the error, but Yasmin basically fixed it. I wanted us to submit and later on come back to the code. But yes, excellent. We of course need to include else. I wanted us to actually see the error from the compiler or when we test the code forces. So why we need to include else, just like Yasmin said, because if we do not include else, the compiler will basically execute both. The compiler will print 0 and will print A minus N. Excellent, Yasmin. So let's go back and submit the code. I think it's gonna ask me to enter again. Oh, okay. Awesome, so soldier and bananas. Let's try to submit our code. So we're basically halfway done. And our code got accepted. Awesome. So we're basically halfway done and it's just been 30 minutes. That's awesome. So this is another awesome question that I really, really like, and it's called Word. Let's just delete that. I'm gonna keep on using the same page just for the sake of efficiency. So Word. Vasya is very upset that many people on the net mix uppercase and lowercase letters in one word. That's why he decided to invent an extension for his favorite browser that would change the letters register in every word so that it either only consists of lowercase letters or vice versa, meaning it only consists of uppercase letters. At that, as little as possible, letters should be changed in the word. For example, the word house must be replaced with house, all lowercase, and the word VIP must be replaced with VIP, all uppercase. If a word contains an equal number of uppercase and lowercase letters, you should replace all the letters with lowercase ones. So for example, with matrix, we have 3 uppercase and 3 lowercase. Task is to use the given method on one given word. Okay. So test cases. House, we have 2 uppercase letters and 3 lowercase. And since the lowercase letters are greater than the uppercase, we are going to be printing house all lowercase. However, with VIP, as mentioned above, we have 2 uppercase and 1 lowercase letter. So the word should be all uppercase. And in the last case, which is matrix, we have an equal number of uppercase and lowercase letters. And as mentioned in the question, if there was an equal number of uppercase and lowercase, you should replace all the letters with lowercase letters. Okay, let's go. So our first step, what would be our first step?
Declare.
What do you think?
Word. So string word.
Excellent. String word. Okay.
And CN word.
Okay. Awesome. What else do we need to do? So how are we going to be able to count uppercase and lowercase letters in the word? What do you think?
We also need to declare a counter. So int count.
Okay, so do we need just one counter? How many counters do we need?
1 for the lowercase and 1 for the uppercase.
Excellent. So do you think we should let's just call them count lower and give it an initial value of 0. And count upper and give it the initial value of 0 as well. So this is the tricky part. What do you think? What would be our next step? We need to access each and every letter and see if this letter is uppercase, and count upper increases by 1. If it's lowercase, count lower increases by 1. And then we would see if lower is greater than upper or accordingly. I'm going to remove this. Okay, what would be our next step?
We need to use a for.
So we need to use a for. I didn't hear what Zaha said.
Oh, I said the same thing.
You said the same thing? Okay, awesome. Yes, we do need to use a for loop. Okay, what do we include inside the for loop? Reminder, string indexes start from 0.
Int I equals 0. And then I is less than or equal to get length.
So less than or equal? What do you think? So we go from 0 to length minus 1, right?
Yes.
Yes. So we're going to stick with less than. So less than what?
Get length or
So do you remember the function we used?
I forgot the
It's
exact
word.
name.
It's okay. So it's word.length, but you're very close. So it's word since we declared it as word. And the function is length or size, whatever you prefer to use. I plus plus. Okay, what would be our second step? We want to access each and every word, each and every letter, and decide if it's lower or upper.
If word, then square brackets I
Excellent.
is greater than capital letter A and
And
less than capital letter Z.
what would we do then?
Count upper plus equals 1.
Absolutely great. Okay, so what are the other possibilities?
So else if the exact same thing, but for letter case ones, and instead of count upper, count lower.
Exactly. So we can just say else, or we can also say else if for clarity. And we change from upper to lower. Excellent. And in this case, it would be count lower plus plus or plus equals 1, whatever you prefer. Okay, excellent. So there are 3 things that we need to worry about now. These are greater than upper letters. We need to basically convert the whole entire word to lower. In this case, since their upper is greater than lower, then we have to convert the whole word to upper. And in this case, since they're equal, we have to convert to lower. So what do you think? What do you think?
So first we say that we need to compare them. If count upper, let's say, is greater than count lower, then word.
Okay.
It's
So
not.
this is the tricky part. It's not word. So how do we access each and every letter and check?
We need to use a for loop.
Excellent. We need to use a for loop again. So this question isn't hard, but it's kind of long. So for loop, I'm gonna just write it out real quick. I is less than word dot length. Not plus plus. So this is the part that gets a little tricky. What do you think? If count is upper, if count upper is greater than count lower, then we need to convert all the letters to uppercase letters. How did we used to do that back when we talked about the ASCII table and characters? What do you think?
We can copy the if statement if word I is greater than or equal to small a, and if so, we say that word I minus 32.
Minus 32, exactly. So why did you say minus 32, Yasmin?
Because we're changing from lowercase to uppercase, and lowercase letters, I don't know what you call them, is greater than the uppercase.
So excellent. Okay, so this is for the first one, which is if count upper is greater than count lower. However, what if it was the other way around? What do you think? It's the same thing with.
Yeah, it's the same thing, but we changed the if statement, and we say word I plus equal 32.
plus equals 32. And just like you said, we need to change the if statement. And in this case, count lower is greater than count upper. And there's something else we need to change, right?
Yes, A and Z should be big capital A and capital Z.
Exactly. Absolutely. We're basically done. There's just one last thing. Because if this condition was true, then it wouldn't have to go to the other ones. And there's just one last thing. One last thing.
See out word.
So yes, we can go with see out word. But there's also one last thing. There's a shortcut to it, by the way. Instead of having if, there's a shortcut. What do you think? What if they were equal? Do you remember? Like matrix? What would we do in this case?
Okay, so we should add in the code. Wait, the screen is still loading.
Is it so? Can you see it?
Not yet. Okay.
Not
So,
yeah.
So we should add if count upper is less than and the same and the else
In the
if.
same.
Yeah.
And which one? In the else if. Okay.
The second one.
Yeah.
Okay, count upper less than or equal to count.
Did you say or? It's or, right?
Yeah.
Okay, so do we need to add another else if statement, or do we just put or in the condition?
In the condition.
Exactly. So if count lower is greater than count upper, or if they're both equal, if count lower equals count upper, then in both cases, each and every letter should be lowercase. Excellent. So yes, you can, of course, have another else if statement or else statement or if statement, whatever you want to do, and include if count lower equals count upper. But since we already have an else statement that is ready, we can just simply use the Boolean operator and include it within the condition. And as I mentioned, we have to, of course, see out the word at the end. So let's try with the test cases. Let's try with the test cases and see. Let's try to run our code. So since there are two uppercase letters, this is supposed to print all lower. Okay, let's try the second. Sorry, just 1 second. Let's try this one. Go back to input and run our code. This is supposed to give us all upper since there are two uppercase and one lowercase. Let's see what this gives us. I'm not sure. I think it's my 1 second. I'm just going to stop sharing for a second. Sorry for the inconvenience, girls. I think it's my internet. My internet's not really cooperating today. I'm going to just 1 second. Okay. I don't know what's happening. Okay, so it's not really cooperating, but we can try to test our code and see. However, I really wanted us to test all the test cases. I'm just going to start sharing again. Just 1 second. Okay. Again, I'm super sorry about the inconvenience. I don't know what's wrong with my internet. It's not really cooperating. So it's basically word This is the problem we're trying to submit. Okay, so it gave us go back to the code and see. Just 1 second. It gave us an error, so I'm gonna copy the code again. Oh, it's not really cooperating. Okay. So there's something wrong with our code. Let's try to run VIP and see. It gave us an error, so let's try to correct it and run. Okay, so VIP works. Let's try matrix and see. It tells us that there's an error on test case 7. However, the test cases are working. Let's go back to the code. So basically, we received word. Okay, so string received word, count upper, count lower. Okay, word dot length greater than or equal. Oh, okay. So there is something wrong. Can someone spot it for me? Something in the if statements. What do you think?
You forgot
Something...
the equal.
Yeah, exactly. I forgot the equal. So that's basically my bad. I'm very sorry about that. So this is probably why it gave us an error. Although the test cases actually worked, but I did forget the equal, and that's why it gave us an error. So let's try to run our code one last time. Word. Fingers crossed for the best. Let's see. Accepted. So our code is accepted. See, so sometimes just tiny little mistakes that you might miss out on would actually create these errors. Okay, so let's move on to, I think would be either our last question or the question before last. And this is a really fun question. It's called stones on the table. So there are n stones on the table in a row. Each of them can be red, green, or blue. Count the minimum number of stones to take from the table so that any two neighboring stones had different colors. So stones in a row are considered neighboring if there are no other stones between them. Okay, so the first line contains an integer, the number of stones on the table. The next line is string S, which represents the colors of the stone. We'll consider the stones in the row numbered 1 to n, which is given as the first line of input, from left to right. Then the ith character S equals R if the stone, and B if it is blue. Okay, so basically, it's asking us, the question is asking us to count the minimum number of stones to take from the table so that any two neighboring stones had different colors. Interesting. Okay, so for our first test case, we have 3 different stones. It sounds a little tricky, but when we trace the test cases, I think we're gonna get the hang of it. So in the first test case, we got R, R, and G. So the first stone is R, which is red. The second stone is R, and the third stone is G. So R is equal to R, and R does not equal to G. So technically, if we remove R and G would be 2 different neighboring stones. I kind of explained it in a very odd way, but we're basically going to be trying to find the number of stones we need to remove in order for neighboring stones to have different colors. So if you go with the second example, we have 5 red stones all next to each other. So we have, in order for R to have a neighboring stone that isn't R, we'd have to remove this R. But then we have another R, so we have R, and then another R, and remove this R, and then another R, and we have to remove this R. So there are 4 different stones that we need to remove in order for R to have different neighboring stones. In this case, it would have no neighboring stones since every single stone in this test case is R. However, in this case, B does not equal to R, and R does not equal to B, and B does not equal to G. So each and every stone has a different neighboring stone. So there are no stones that we need to remove. Again, so here we have to remove this R in order for R to be next to G, since R and R are equal. So there's one stone that we need to remove. In this case, we have to remove 4 different stones in order for R to either be on its own or have a different neighboring stone. So in this case, we have to remove 4 different stones. And in the last case, B is next to R is next to B, and B is next to G. So each stone, the neighbor of each stone is different. This is one of the hard questions. We definitely can do it. So, stones we need to remove in order for each and every stone on the table to have a different neighboring stone. Do you have any ideas? Let's try to write our code. What do you think?
Okay, first I thought, so we need to CN the first we need to declare n, so int n, and then CNN.
Excellent. Okay, CNN, yes.
Okay, concerning the letters, I thought that we need to store them, but we can't do like the exercise before because we don't know, because then we don't know exactly how many friends are there, just like the previous exercise. So I thought maybe that we could store them in an array.
Excellent. Okay, perfect, Yasmin. So how do we exactly store them in an array?
Okay, so char, color.
Excellent.
Okay, brackets and.
Okay, perfect. So we always have to give our arrays an initial value. Perfect, Yasmin. So we decided to go with character array for now, since we already and we are receiving the size from the user. So all Yasmin did was create an array of characters. And since we are for CN from the user, the size of the array will be size n. Excellent, Yasmin. Okay. So what would be our... So how do we access each and every stone in the character array? What do you think? It's very similar to the previous example, but there are some stuff that we need, some like extra steps that we need to take. But for now, how do we access array elements?
We use a for loop. So
okay.
For int I equal to 0, I less than n, I plus plus.
Excellent. Okay.
And CN color m.
CN color n.
Brackets, yeah. Sorry.
Excellent. Okay. So it's color I. And then what? So we need to receive all the colors and then decide how many colors we need to remove in order for each and every stone to have a different neighboring stone. So we're receiving the colors from the user. We're going to receive them all at once. But there's another step we need to take. There's something else we need to do. We need to decide if the neighboring stones are the same or not.
We need another for loop in order to compare the colors.
Excellent. Okay, so for, again, I'm just repeating the same exact thing we did above. Okay, but if the colors over here. So since R is equal to R, then we increase or we have to at least replace 1 in this case. But then we go to the second element and we see that r does not equal to g, so we're good. In this case, r does equal to r, so we have to remove 1. R equals to r again, remove another one, so that's 2. R equals r again, remove another one, which is 3, and the last one would be r does equal to r, so we have to remove at least 4 stones. So that's the tricky part, and we didn't do anything like this, but it's a simple an element with its neighboring element. So for example, with G, the first R has index 1, has index 0, second R has index 1, and the third element, which is V, has index 2, right? So this is your hint.
I was thinking of starting from I equal to 0, and then in the if statement, the condition would be if color I is equal color I minus 1.
I minus 1. So you wanted to start from I equals 0 or I
1.
equals 1? Oh, you wanted to start from 1. Okay, we can do that. We can start that. We can definitely try that. And let's see. And you said I minus 1?
Yeah.
Okay. All right. And then something else we forgot to do.
Yeah, I less than or equal.
I less than or equal? Oh, you mean here?
Yeah.
So the for loop over here is correct. We're going to get back to this. Okay, so keep that in mind. But where do we store this number? And how do we exactly figure it out?
We need a counter.
Absolutely. We do need a counter. So I'm going to include it here. It doesn't matter where you include it. Count equals 1. So in this case, if color I equals I minus 1, we can try and figure it out. If they are equal, then we have to remove a stone, right? So where do we put that? How do we implement that as code?
Can I ask why count is 1, not 0?
Oh, sorry. No. It should be 0. I'm sorry. Absolutely. Thank you, Yasmin. So what do we do here?
We increase count by 1, so count plus plus.
Exactly. What would be our last step? What do you think? What are we trying to see out here?
Count.
Count. Exactly. So let's try to run our code and see. And this is absolutely correct, but we are also going to be trying 0 less than n, just to avoid confusion. But this is definitely correct. So let's try with R and G. So input. So n is 3. And there are 3 different stones, R, and G. It's going to see out 1. So this is right. We're going to try 5. And in this case, each and every stone is the same. So we're going to have to remove at least 4 stones. And the last test case, each and every stone has a different neighboring stone, meaning we do not need to remove anything. So it's supposed to give us 0. Excellent. So again, going back to here, this is 100% correct. We can also start from 0. But in the case of 0, what should we edit over here? If we wanted to start from 0 instead of 1. What do you think?
So the first color I, we should say color I plus 1, and then the second one should be I.
Absolutely. So we're going to keep it as is, but instead of I minus 1, we say I plus 1. Excellent. But we're going to stick with 1 since it's also the same thing. and change is good. So we're gonna stick with one. Excellent, girls. I honestly thought this was gonna be a tricky question, but we're going to the trickiest question right now. Just 1 second. Choose problem. What was the name? Table, right? Okay, let's try to submit and see if Code Forces accepts our solution. Accepted. Awesome. Stones on the table is accepted. We're just gonna solve one last question because I really also like these. I like this question, and there's a tricky part here that we're gonna be solving together. So this is our last question of today's hackathon, and I'm so proud of you girls because we were able to solve 4 questions in an hour. So that's absolutely amazing. So let's move on to our last question, which is called football. And let's see what the question asks us to do. So Petya loves football very much. One day, as he was watching a football match, he was writing the player's current position on a piece of paper. To simplify the situation, he depicted it as a string consisting of zeros and ones. Okay, so a 0 corresponds to a player of one team, and a 1 corresponds to the player of another team. If there are at least 7 players of the same team standing one after another, then the situation is considered dangerous. So for example, the situation over here is dangerous, and now we're going to examine why, and the situation over here is not. So you are given the current situation, determine whether it is dangerous or not. The first of consists of a non-empty string consisting of characters 0 and 1, which represents players. The length of the string does not exceed 100 characters. There's at least 1 player from each team present on the team. We print yes if the situation is dangerous, otherwise we print no. So let's see why this is not dangerous and why this is dangerous. It is mentioned that if there are at least 7 players of some team or the same team standing one after another, then the situation is dangerous. So here we have 0 and 1. 0 is basically depicts one team and 1 depicts the other team. So here we have 2 zeros, 1 1, 2 zeros, and 1 1. So whenever we have 7 players of the same team right next to each other, we would consider the situation as dangerous. However, here we have 2 of one team, 1 of one team, 2 of one team, and 1 of one team. So the situation is technically not dangerous. However, over here, we have 1 from one team, and then we have 1, 2, 3, 4, 5, 6, 7, and 8 from another team, and then just 1 player from the previous team. So this situation is dangerous. For more clarification, let's go back to the test cases mentioned above. So this situation is dangerous. Why? Because we have 0, 0, 1, 0, 0. We still didn't get to 7, then 1, 1, 0. But then over here, we have 1, 2, 3, 4, 5, 6, and 7, and then 0, 1. So we do have 7 players from a specific team that are standing right next to each other. So this is dangerous. However, here we have 1, 2, 3, 4, not 7, and then 0, and then we have 1, 2, 3, then 0, 1, 2, 3, 0, and 1. So we do not count up to 7 players from the same team, which makes the situation not dangerous. Okay? Okay. So the first line contains a non-empty string of characters 0 and 1. And the programmer is expected to see out yes or no. Yes if the situation is dangerous, and no if the situation is not. Okay, first step. What's our first step? What are we receiving from the user? Our first step is basically declaring what we're receiving from the user. What do you think?
We can store them in an array, the numbers we're receiving.
We definitely can. We absolutely can. The question asks us to do. What does the question say?
They want it as a string.
As a string, but you can definitely store it as a character array. But there are some extra steps. So, our first step.
String.
Mm-hmm.
We can call it anything.
Play, just for example, just a random variable. Okay, awesome. And what would be our next step?
See and play.
See and play. Okay. So what do we do over here? We want to determine if there are 7 or more players that are next to each other, same team, the situation is not dangerous. What do you think? So first, how exactly do we let's say, how do we know, or how can we track the players in the string? What can we use in order for us to track the players?
A counter.
Absolutely. Yes. So we're gonna go with counter. So what do you think? Let's just give it, just for now, an initial value of 0. And when we test our code, we'll see if we need to fix anything. So we're gonna, as usual, give, since we always give our counters a value of 0, we're gonna give our counter 0. And do we access each and every character in a, you have to use a for loop, right? Okay, so who can help me fill in the for loop?
Int I equals 0.
Mm-hmm.
And then I is less than play.length I++.
Absolutely, play the, excellent. Okay, so this is the tricky part. So let's take this example, since it's dangerous, and I want to comment it here so it can help us figure out how we can do it. Hint, this is very similar to the stones on the table question. So 1 is fine. There, a 0 comes after 1, which is a player of a second team. 0 comes after 0, and then there's another 0. That's 3, 4 zeros, 5 zeros, 6, 7, and 8. So if it's 7 or more, then the situation is dangerous.
So can we say that if play I equal play I+1?
Absolutely. If play I equals play I minus I+1, what would we do? Sorry about that.
We would increase the counter by 1.
Absolutely. Count plus plus. So the tricky thing about this question is that there is more than one possibility that we need to consider. Okay? So in another question, the first test case, which is not dangerous, we have 2 zeros. So here, if we follow this if statement, the first one is going to be 0, and the second one is also going to be 0, so the counter is going to increase. But the third element is going to be 1. So in this case, what would the counter be? Would this be dangerous?
No.
So does the counter stay as it is? Do we keep on increasing the counter? So for example, if we had 0, 0, and then 1, and then 0, 0, this is not a dangerous case. but this is going to increase by 1. This is going to be increasing by 1. This is going to be increasing by 1. So we have 3 and then 4. And then if we continue until we get to 7, it might see out that it's a dangerous case, but this isn't dangerous. How do we fix this?
I was thinking of using a Boolean. So what I was thinking is that, and if count inside the if
A Boolean,
statement,
okay.
if count
Which
was inside the if statement, so like if count was less than
Okay.
7, then okay, so we need to declare a Boolean, let's say, and we say that it's false.
We say that it's false. Okay, so let's go with that idea. I like that idea. So let's say, right? Because we can't give it an initial value of true, or then the code would be wrong. So excellent. Okay, so if count is less than 7, what would happen?
State would be false.
State equals false. Excellent. Okay, we covered this case. What do we do next?
Okay, if count is greater than or equal to 7, then state would be true.
So state would be true. And in this case, do we need to continue?
Yes, in this case, then it's dangerous. So we need
It's dangerous.
see out, yes.
See out, yes. Okay. See out, yes, and unline. Okay. But here's the thing. Can you see that? Can you see what might be happening with our
Yes.
code?
هي إنه كلمة every time it's going to enter, it's going to print yes. يعني
Absolutely.
no, this shouldn't be inside the for loop.
So this shouldn't be inside the for loop. Exactly. So where do we include this?
Outside the for loop.
Outside. Excellent. Okay. So we can include this outside the for loop because Yasmin mentioned something very important. The count will not change. It will only keep on increasing. So it's always going to keep on printing yes, 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 yes. We just wanted to print yes once. So you put this outside. But also, I don't want the counter to keep on going and going and going when it reaches 7. Okay? So the count does not necessarily need to be 9 or 10 or 11 in order for us to print yes. If the counter reaches 7, then I don't want it to keep on going inside the for loop again and again and again. Does that make sense? So if the counter, or if count equals to 7, I just want it to directly leave the for loop. And that's it. I hope that makes sense, but let's stick with our solution for now. So if the counter is greater than or equal to 7, state would equal to true. But here's the thing, how exactly are we benefiting from the Boolean variable? It's basically just a Boolean variable that is either false or true, but it's not really helping us with the for loop. What do you think? There are some stuff that we need to edit.
لأنه in this case هو my idea was إنه if count, okay, so if count was less than 7, I want it to be false because I didn't want it, as you said in the previous example, like if the numbers weren't after each other, I don't want count and no.
I want it to keep going.
Yeah.
Right?
Yeah.
So what do you think? So here's the thing. We can definitely use the Boolean variable, but I'm gonna comment it out for now. Okay? I want us to find something that would ease the process a little more. Okay, this for now is 100% correct. Else, let's just include this. Else, cout no. By the way, in this case, you don't need to include and L, but I'm just including it. It's basically a convention, so I always include them. So Yasmin mentioned something very important. We don't want it to keep on counting. But do you remember in our beginning sessions, we said that the counter or the variable can always be reinitialized. Do you remember we said something about that? I'm going to remove this for now, although we can definitely use this. We can definitely use this and we can keep the Boolean variable, but I want us to stick with easier approaches. So what do you think?
Okay, else if count becomes 0.
Else? So else if or just else?
No, just else.
Okay, excellent. Else?
Count becomes 0.
Count equals 0. Exactly. We reinitialize it. Since again, as we mentioned, if this continues, it's going to keep on counting. But it is not, if it's not, then we reinitialize it and we give it its initial value. Okay, so let's try to run our code in C. So for now, I'm going to remove these just for the sake of clarity. Our counter is 0. If I equals I plus 1, increase counter. Else, reinitialize the counter and give it the value of 0. If count is greater than or equal to 7, cout yes. Else, cout no. So let's start with the first one and see. Let's try to give our input and run the code. So it printed out no. Let's try the second one and see. It's printing out no, but it's supposed to print out yes. Why do you think that is? Why do you think this is the issue? So let's try to trace our code again. Okay, so here, we start from here. Is 1 equal to 0? No, that's fine, go on. Is 0 equals to 0? Yes, so count is 1. Is 0 equals to 0? 2. 0 equals to 0, 3. Oops, sorry. 0 equals to 0, 4. 0 equals to 0, 5. 0 equals to 0, it'd give us 6. And then it would move on. Is 0 equal to 1? No. So our counter is going to be 6. Although there are 7 zeros right after each other. I'm going to try to zoom in. Here, 0 equals to 0. Yes. 1, 2. Oops. We're going to go with, and then it goes again. It's going to go with 3. And then it's going to go with 4. And then 5. I'm messing everything up. But it's basically going to stop at 6. It's not going to stop at 7. However, this is a dangerous situation. So how do you think we can eliminate this issue? I'm going to try to annotate. I don't know if I can. Okay, so perfect. So 0 equals to 0, 1, 2, 3, 4, 5, 6, and 7. So there are 7 zeros. But if we try to print our counter, it's basically going to give us 6. Let's actually try to see out the counter and see. Although it's not asking us to see out counter, but let's try. See out count. We're going to stick with the same test case and see what it gives us. Interesting. So it's giving us 0. There's something wrong. So it's either going to count less than, or it's going to include this one and return to 0.
So I think
there
we
are
should
2
start
cases.
the count. I think we should start the counter with 1.
with 1, right? So we need to start the counter with 1 and see. I did slightly confuse you with my analogy, or I did slightly confuse you with my explanation over here. However, it's either going to give us 1, or it's either going to give us less than the counter, or it is going to give us count equal to 0. But there's something else we need to fix. Since we're starting the counter from 1,
The
where
other
do we start this
time
counter?
in the
Yeah,
else.
exactly. So let's see. Let's try to run our code and see. Run.
It's not gonna work.
Why do you think?
It's
Why
gonna
do you
give
think it's not
1.
going to work?
We should say else if counter is less than, and not here, not here.
Not here. Okay, we're doing
Okay, the else of count equal 1, line 18.
line 18. Okay. Else if
Yeah, count is less than 7.
is less than 7,
Then we can say, because what's happening is that it's true, this is a dangerous situation, but then when it reaches index like the last 0
last
and
one, yeah.
when it reaches 1, it's different from 0, so it's going to say that count equal 1, and it's going to consider it as not dangerous.
Exactly. So let's try to test. If we say else if count 7, let's try to test our code and see. So it's going to give us 8, so it's going to work. Let's try another input. Let's try input, just a random input. So I'm going to say 1, 2, 3, 4, 5, 6, 7, and then 0, 1, and try to run our code and see. It's going to give us 7. So yes. So let's try to run our code on the code forces compile and go back and submit our code. Let's see. What was it called? It's called football, right? And submit our code and see if there are any errors. Has been submitted successfully.
I think it's gonna give an error because we forgot to remove the line that says see outcome.
Oh yeah, that's true. 100%. So let's remove that. Thank you, Zaha. So let's try and run our code again. Football. Excellent observation. So let's do it again and see. They're both in queue. And that's my internet's fault. So basically, it's a tricky question. All we did, because if you count it from 0, in the case of, in one of the test cases like this one, the last comparison is going to be 0 and 1. So it's not going to consider it as a dangerous case, although it is dangerous. So it will give us that it isn't a dangerous case, and it would see out no. This is taking so much time, but that's fine. We're just gonna wait and see. This is basically correct. There are definitely more efficient ways to do this. So for example, if I got to 7, we don't need to keep on going. So in our previous example, it said that C out is 8, right? So if you want to build a more efficient code, we can simply break free of the while loop if the count is 7. This is just for the sake of efficiency. So for example, if count, instead of it going all over again and again and again and again and again. And then in this case, just as Yasmin said, we can keep the else if statement, but it is running. Why is it taking so much time? Let's try to refresh and see. It's running on so many different test cases. So anyway, for the sake of efficiency, instead of it counting and counting and counting, since if we go back to the question, if, for example, if there were 20 zeros, it's going to keep on counting till 20, if that makes any sense, although they're not going to be 20 players of one field, but of one team. But if there were more than 7, it's going to keep on counting and counting. But if we include this if statement, it would see out yes and be much more efficient. So basically our code is accepted and that's awesome. But again, if we want to be more efficient, we can just simply stop at count equals 7 and break and leave the code. So excellent, girls. Honestly, you truly were absolutely amazing throughout this whole entire course. And you were very, very active, and I absolutely and utterly appreciate that. So I'm gonna